In this video, we're going to use our knowledge of constructions to go ahead and construct the translation of some different geometric shapes. In case you haven't figured out already from the title of this, you're going to need your compass and straight edge. So if you haven't already dug those out, let's go ahead and pause the video right now, dig those out of your backpack, and then we'll get down to work. Now, up at the top of the page, you see a list of 7 steps, which you are more than welcome to use. I'm going to say, let's go ahead and see if we can't use what we know about our work with translations and construction so far to see if we can't jump right in and figure this out. So I'm going to jump right into this. The directions say, use your compass and straight edge to apply the translation of vector AB to the segment with endpoints P1 and P2. So first things first, to translate or even really to transform any geometric shape, we're going to go one point at a time. Namely, we're going to be very careful about the points that we pick so we can transform as few of them as possible. For this particular construction, if I can figure out where the first endpoint, P1, goes, and figure out where the second endpoint, P2, goes, then I know that everybody else is going to have to go in between them in the image. So I'm simply going to construct, or I'm going to transform or translate the endpoints and then use my straight edge to connect the endpoints at the end. I do know, based upon the study of our knowledge of translation so far, that everybody in that line segment is going to have to travel the same distance and direction as vector AB. So I'm going to begin my construction by figuring out how far or what the distance or the magnitude or the length of this particular translation is going to have to be. And then I'm going to go ahead and move the point of my compass to point P and draw a circle around point P with that same compass setting, or with the compass setting the length of vector AB. And I'm going to do the same thing for the other endpoint, P2. Draw that circle with a compass setting that's set to the length of vector AB. Okay, so I know that everybody on both purple circles is at a distance away from the endpoints if the length of vector AB is long. That's the first important thing to know. We also know from our work in the coordinate plane with translations that each point in the translation is going to travel exactly the same distance, and that the vectors for each set of points are always going to be parallel. That's the point that we're going to, or the idea that we're going to use next. This idea that all of the vectors are going to have to be parallel, and we're going to keep in mind that parallel lines are equidistant everywhere. So how I'm going to use this piece of information is I'm going to go ahead and I'm going to measure the distance now from point A to point P1 using my compass. So all I want to do is open up my compass so that the point of my compass is on point A, and the pencil part of my compass is opening or measuring that distance from point A to P1. And then I want to maintain that distance. I want that distance from wherever P1 ends up to point B to be the same thing. So I'm simply going to slide my compass down the vector until the end point of my compass is at the end of my vector, and I'm going to arc. And that point of intersection between the purple arc and the red arc is going to become the image of P1 under that translation. So I'm going to call that P1 prime. And then I'm simply going to do exactly the same thing for P2. I'm going to go measure the distance from point A to endpoint P2. And I'm going to keep in mind that parallel lines are going to be equidistant everywhere. So there's the distance that I want. And now I simply want to slide my compass down that vector and draw the arc. And where the purple and the red arcs intersect is going to be the location of my second endpoint. or in other words, P2 prime. I'm going to go ahead and grab my straight edge, and I know that all of the points in between P1 and P2 must have followed right along. So there's my new line segment under that construction. So an important thing to note here is that each vector for each point will be both parallel and the same length. This whole notion of parallel lines being equidistant everywhere, and the whole idea of translating one endpoint at a time and then using the straight edge to connect when we're done is a big idea. All right, if we go up to the top of the next page, they're asking us to do the same thing. They're asking us to translate using this vector A prime, but this time, instead of asking us to translate a line segment, we're being asked to translate a triangle. The process is still exactly the same. I still need to take into consideration both the length and the direction of the vector by which I'm trying to translate. So in this particular case, the vector by which I'm trying to translate is vector A prime. So I'm going to go ahead and I'm going to start or begin by measuring the length of that vector. The length of that vector is the length by which I'm going to want to translate each and every point in that triangle. So there's the length of that vector. I'm now going to go ahead and draw a circle around point B, using that vector as the compass setting, and a circle around point C, using the vector as that compass setting. Now, point A has already been translated for us. That's kind of nice because it's one less point that we'll have to translate. Point B is the next point that I'm going to go ahead and translate. So I'm going to go ahead and put the point of my compass on point B, and I'm going to measure the distance from point B to point A. And I'm actually going to go ahead now and at this point flip my compass around, and I'm going to put the point at A and the pencil at B, because what I'm going to do is I'm going to slide my compass down that vector till I get to A prime, and that's where I'm going to draw my arc. Just make sure here you draw your arc on the circle about point B and not the circle about point C. So that's where point B is going to end up. I'm going to call that point B prime. And then I'm going to do the same exact thing for point C. I'm going to use my compass to measure the distance between points A and C. Once I've got that distance set, I'm going to go ahead and slide the point of my compass down vector A prime. And this time I'm going to make sure I draw an arc that intersects the circle about point C. And the intersection of those two arcs is going to become point C prime. And now and only now that I have translated each and every vertex of my triangle, I can simply take a straight edge and use my straight edge to connect or join each vertex. And by doing that, now I've translated the entire triangle. Number 2 says, explain what was preserved during this construction. Well, I know that each and every translation is an isometry, so I know that distance or length was preserved. I also know that each translation is not only an isometry, but it's a direct isometry, meaning that orientation is also preserved. And I think because I'm just about here at the end of my time, I'm going to leave that third construction up to you. But we'll check your construction the next time that you come back to class and make sure that we're all on the same page and that everybody's got this down before we head into the practice problems. There is no check your understanding and summarize the key ideas and the important takeaways here. This is the last page in this notes. So just see what you can do to finish up translating this last triangle. And we'll kind of put some closure on it the next time that you come back to class.